Day 704 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2069, Walking Robot Simulation 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. Excuse me, y'all. Don't forget to hype, like, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A width times height grid is on an XY plane with the bottom left cell at 0, 0 and the top right cell at width minus 1 and height minus 1. The grid is aligned with 4 cardinal directions, north, east, south, and west. A robot is initially at cell 0, 0 facing direction east. The robot can be instructed to move for a specific number of steps. For each step, it does the following. Attempts to move forward one cell in the direction it is facing. If the cell the robot is moving is out of bounds, the robot instead turns 90 degrees counterclockwise and retries the step. After the robot finishes moving the number of steps required, it stops and waits the next instruction. One moment. So what we need to do is we need to implement the robot class. So the robot init, that's this init right here. This init right here is going to initialize the width times height grid with the robot at 0, 0 facing east. This step function, void step, this function, this is the step function right here. Boom. The step function is going to instruct the robot to move forward num steps. Boom. Then the get post function right here, I think for get position, is going to return the current cell the robot is at as an array of length 2, so with x and y as the coordinates. Boom. Then the get dir function, this function right here, is going to return the current direction of the robot, north, east, south, or west, y'all. So boom. I know that seems a little bit confusing, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, Example 1, our input equals an array of strings. First string robot, then step, step, get pose, get dir, step, 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 get pose, get dir. And each one of these strings represents a different function call. So this right here is just initializing this robot class. So this is the robot class, as you can see, and we need to initialize it. So that's what this means. Then this means we're going to call the step function. Boom. This means we're going to call the get pose function. Boom. This means we're going to call the get dir function. Boom. Then this right here is also part of the input. Is a 2D array of integers. First array is 6, 3, then 2, then 2, then a blank array, then a blank array, then 2, then 1, then 4, then a blank array, then a blank array. Now each one of these arrays in here corresponds to our function calls. So let me go ahead and copy and paste these over here so y'all can get a better visual representation of what's going on. So boom, this is our input, and these all correspond with the corresponding index. So this index 0 corresponds with this index 0. This index 1 corresponds with this index 1. This index 2 corresponds with this index 2, and so on. Let me see if I can line them up. It's probably be hard to line up, but it'll be easier for y'all to understand once we get these all lined up together, so y'all can see how this question actually works and what's going on. So boom. Yeah, this is better actually for the visual representation. Boom. So then that's our input. Let's go in. The output is an array, so we have null, null, null. This is an array of integers for 4, 0. This is a string east, null, 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 an array of integers, and a string west. Boom. So let's copy and paste this over here. This is our output. Boom. And then we'll come down here and we'll build the output ourselves as we go through this explanation, right? So boom. So let's go through the explanation. Robot equals new robot 6, 3. So we initialize the grid and the robot at 0, 0 facing east. So when we call this robot, boom, this robot right here, boom. Once again, like I said, this corresponding index, this index corresponds with this index. So when we initialize this robot class, right, we're going to initialize it with the 6-3 grid, right? It says right here, the init initializes the width times height grid with the robot at 0, 0 facing east. So as you can see with this grid right here, it's 6. It has a width of 6 and a height of 3. Boom, right? Because once again, right here it says width times height. So this is the width, this is the height. Boom, and we're initializing, so we got the grid. As you can see, it has 3 cells for the height, 1, 2, 3, and it has 6 cells for the width, 1, 2, 3, 4, 5, 6. So boom, that's all that did. We called this function. Boom, we initialized it with a 6-3 grid. Boom, so we can now just say null right here in our output that we're building, because we didn't return anything. All we did was initialize it. So that's why this output is null, because we didn't return anything. All we did was initialize. Boom. Next, we're going to call step. So step is going to, remember, they correspond. So this step is going to correspond to this 2. Boom. So we're going to step 2 steps. It says right here, it moves 2 steps to the east, 2, 0, and faces east. So boom, we call this, we move 2 steps to the east. So we go 1, 2. So right now we would be right here, and we could put a null right here, because once again, all we did was move 2 steps. We didn't return anything. Boom. So we can get rid of this. Boom. Hold on, y'all. Hold on. Because when you look up here, look, it says instructs the robot to move forward num steps. Doesn't return anything. But these functions, you can see, return something. So this returns the current cell the robot is at, and this returns the current direction of the robot. But that's why these two we just put null, because nothing is being returned. And I'll show you once we get to a get pose or a get dir. Boom. So now we're going to call get step, or we're going to call step again for 2 steps, right? That's this 2. Once again, that corresponds to this. This is index 0, 1, 2. This is index 2, and this is index 0, 1, 2. This is index 2. Boom. So we're going to move another 2 steps. We're right here. Boom. Then we move another 2 steps. 1, 2. Boom. Now we are right here at 4, because we moved 2 steps twice. Boom. So we called this. Once again, since we called that, once again, we could put the null right here. Boom. Then return anything. Boom. So what's next? Get pose. So now we want to get the position. So we're going to call get pose. As you can see, it's a blank array, because we don't need a number of steps and we don't need a position. So we just need to get the position. So when we get the position, remember, we're right here currently. So when we get the position, we're at 4, 0, right? Come down here, 4. The width is 4. The height is still 0. We haven't moved up the height of anything yet. So we're at position 4, 0 after moving 2 steps twice. After these 2 steps right here, boom, we're right here, 4, boom, 4, 0, boom. So that's where this 4, 0 comes from. So we could put this 4, 0 right here. Sorry, y'all. Because when we call get position, we were at position 4, 0. That's the position we're at. And remember, like I said, this returns something. We return the position. So it's not null. We're returning our position, which is currently 4, 0. So boom, we called this. So we get rid of this. Let's get rid of this. Let's clean this up so it still lines up correctly. Boom. Hold on, get rid of this. Boom. Okay, now we're calling get dir. So we're right here, and it's going to be another blank array corresponds to this right here. So get dir, once again, blank array, because we're not moving any steps and we already initialized our class. So boom, now we want to get the direction. We're right here, we're still facing east. We haven't changed directions, right? It says we changed direction when we move to out of bounds. We haven't moved out of bounds yet because we're still right here. So boom, we get the direction, we're still facing east. So once again, this returns the direction. So since it returns the direction, we're gonna put this, open up the quotation marks and put east right there, because that's the direction being faced. Then we called that. We called get dire so we could get rid of that. We already called it. Boom. Now we're back at step 2. Boom. So now we're right here at step, and that corresponds to this. Boom. Index right here. So once again, we're going to take 2 more steps from right here. So when we go right here, take 1 step, boom. Now we're out of bounds, right? We moved out of bounds. So the robot instead is going to turn 90 degrees counterclockwise and retry the step. So we right here, we move 1 step. Now we're out of bounds. He turns counterclockwise. Now we're going up. And now we are right here. Boom. But we can still return null because we didn't return anything. Or we could put null because we didn't return anything. Boom. So we called that step. Boom. So we get rid of this. Let's get rid of this. Boom. Now we're on step again. We're calling another step right here. But this time, this step corresponds to this one. Boom. So we're going to take 1 step forward. So right here, we're facing north. So we take 1 step forward. Boom. Once again, we could put the null because we didn't return anything. We just took our step forward, and now we are right here. Boom. Now we could get rid of this because we already called it. Now we're taking 4 steps. Boom, we got. So hold on. Boom, we took our 4 steps, and we are currently right here. So now we are on this step. This step is going to correspond to this 4 like we have up here. So we're going to take 4 steps. Now we're facing north. Once again, we're out of bounds. So once again, we got to turn counterclockwise because we're out of bounds. So we turn. Now we're facing west, and we go 1, 2, 3, 4. We end up right here. Boom. But we can still put null because once again, we didn't return anything. We just are at a new position. Boom. So now we put the null right there. We could get rid of this and this. Boom. Now we got to get the position. Because remember, we're up here now. So this position is now we're at 1, come over 1. So it has the width of 1, come up, and we're at 2. So we're at 1, 2, right? So when we call this get position, we're currently at 1, 2. So that's where this 1, 2 comes from. I'll just copy and paste that, and we can put it right here. Sorry, y'all. Boom, we put it right here. Boom. So now we're at position 1, 2. And that's why, once again, we return the position when we call get pose. It returns the position. That position is 1, 2. Boom. Finally, last but not least, well, hold on, let's get rid of this. Last but not least, we need to call get dire or get the direction that we're facing. Remember, we're facing west because we came up here, bucked the left, went this way, and now we're facing towards the west, right? So boom, when we call get dire, we already know we're facing west. We called it, so let's get rid of that. Boom, let's put in west into our output. And boom, y'all, that's how the question works. Now, as you can see, this was the original output, and it lines up with our output perfectly. So that's how that question works, y'all. I hope that makes sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we're going to do is we need to get the width, height, and perimeter length of the grid. So we're going to say we'll say, we'll come over here and we'll say private let W, H, P. So W will be the width, height will be the H, and P will be the perimeter. Then we're going to come underneath this, and we're going to say get the current position of the robot. So we're going to declare another private var, or this is a private var instead of private let. And so, sorry, y'all, we need to say colon. We need to cast that as an integer. Boom. Then we're going to say x equals 0, y equals 0. Boom. Then we need the current direction the robot is facing. So we'll say private var dir, and we'll just set that equal to an east at first, because remember, when we initialize the robot, it'll be facing east. Boom. So we make the the default value east as well, so I should be an equal sign right there. Now we need to track if the robot has ever moved, which is important for edge cases. So we come underneath this, declare a private var, call that moved, and we'll set that equal to false. Boom. Now we need to handle this init. So remember, this init is going to initialize the width times height grid of the robot facing east. So we're going to come right here. In this init, we'll say W. We're going to set that equal to width. Come right here, we'll say H, set that equal to height. Boom. Then we need to compute the perimeter path length. The robot only walks along the border, so total steps and full loop are going to be the top plus right plus bottom plus left edges. So, which is going to be equal to 2 times the width plus height minus 2. So we'll come underneath this and we'll set P equal to, open up the parentheses, W plus H minus 2. Come outside of that, times 2. Boom. Now let's create this step function. So for the step function, first thing we need to do is we need to mark that the robot has moved at least once. So we'll set move. We'll set that equal to true. Boom. Then we're going to reduce the steps using modulo to avoid unnecessary full loops. So we'll come underneath this. We'll say declare a variable called s, and we'll set that equal to num mod p. Boom. Now we need to create a special case. If the steps exactly complete a full loop, the robot still ends in a corner, but direction must be updated correctly. So to do that, we're going to say if s equals 0 and two and signs num is greater than 0, then we're going to open up the brackets, and if we're back at the origin, then the direction becomes south, because remember, like if we go around this whole grid, boom, now the direction is facing south. So we're going to say if x equals 0 and two and signs y equals 0, then we'll say open up the brackets, and we'll see dir equals, open up the quotation marks and pass in south. Boom. Then we need to process remaining steps, because that was just a special case. So we're going to come right here and process remaining steps. We'll say while s is greater than 0, we'll open up the brackets, and we're going to say if dir equals, open up the quotation marks, east. So if we're facing east, we're going to move right until hitting a boundary. So we'll open up the brackets and we'll say let d equal min, open up the parentheses, s comma w minus 1 minus x. Boom. Then we're going to update the x position. Come underneath this, we're going to say x plus equals d. Then we're going to reduce the remaining steps by saying s minus equals d. Then if we still have steps left, we're going to turn counterclockwise. So we'll say if s is greater than 0, then open up the brackets and we'll set dir equal to, open up the quotation marks, set that equal to north. Boom. Then we'll come right here and we'll say else if dir equals, open up the quotation marks, north. Come right here, open up the brackets, and we're going to move up until hitting the boundary. So this time we're going to say let d equal min, open up the parentheses, s comma h minus 1 minus y. Come underneath this, we're going to say y plus equals d. Come underneath that, we're going to say s minus equals d. And come underneath that, we'll say if s is greater than 0, we need to change directions if we're out of bounds again. So we'll say dir equals, open up the parentheses, and now we'll be facing west, which will be counterclockwise from north. Then we're still not done, because we still have 2 more directions we need to handle. So we'll say else if dir equals, open up the quotation marks, this time if it equals west. Come outside of that, we'll open up the brackets, and we're going to move left until hitting a boundary. So we'll say let d equal min, open up the parentheses, s comma x. Come underneath that, we'll say x minus equals d, and we'll say s minus equals d, and we'll say if s is greater than, sorry y'all, if s is greater than 0, open up the brackets, and now dir will equal, open up the quotation marks, south. Boom. Now, last direction, come right here. Else, if dir equals, open up the quotation marks, south, come outside those quotation marks, open up the brackets. We're going to move down until hitting a boundary. So we'll say let d equal min, open up the parentheses, s comma y. Come outside of that, we'll say y minus equals d. Come outside of that, s minus equals d. Boom. Come underneath that, and we'll say if s is greater than 0, open up the brackets, dir equals, open up the quotation marks, east. Boom, y'all. Now we're still not done because we have to fix these functions. Now these functions are quite simple. All we need to do here is open up the brackets, and we can just say x comma y. Then we come right here, and all we need to do is say dir. Boom, y'all. That's all we got to do for that. So let's go ahead and run that, make sure that works. Let's see what that does. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 23 milliseconds. Beats dash percent of users. I'm still not sure what that dash means, but I'll take it. The memory is looking good. So before we go, make sure you get one more look at the code. This is the top part. This is the middle. This is the bottom of the middle. This is the bottom of the code, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.